profile, one half of its profile, and then hid the background bitmap and joined our lines together so we get the result that you see right here. Now I'm going to go ahead and clean this guy up a little bit. So to do that, I'll type in the word move, M-O-V-E, and using OSNAP, I want to snap to the tip of my pin, left click, and then type in 0 and enter to get this thing aligned right here at the origin of the grid. Next, I will type in rotate, not rotate 3D, but just a simple rotate, and again, I'm in the top view. The center of rotation will once again be the tip of the pin, and then my first reference point will be the far end of the drawing, the back side of the pin. So I'll left click there. With that reference point established, now I can tilt this thing in, and if I select ortho at the same time, or orthogonal, that will snap it into place at 90 degrees. And what this tells me is that this side of the drawing is exactly right here at 0, 0, and then as I climb up Y, I'm also at 0 in X on the back end of the drawing. And this becomes really crucial in just a moment, as you will see. Sometimes I like to take a moment here and fix some of my slight divergences that came from drawing from an imperfect image. You can see, for example, that my pushpin face here is not entirely flat, but leans away from the grid just slightly. So to fix this, with the illustration selected as it is, I'll type in lock, and these lines go gray and I can't move them by accident. And then once again, I'll grab my polyline tool, I'll disable my O snaps, I can click here too, and I'll enable my snaps so I can get everything exactly right. So here, every time I'm clicking, I'm going to turn off ortho as well, you can see that I can't get right on the line, but that's okay, because what my interest here is that I want the illustration to line up really precisely with the grid, and so I'm just trying to get everything as close as I can while hitting all those grid points. Control point curve, O snaps on, end specifically. I'll draw this out. O snaps off. Oh, I'm sorry, O snaps back on. Polyline tool, left click, and I will disable them again to stick with the grid. You can see, okay, so because I was talking and not paying attention, I started using my end accidentally instead of my snap, and you can see here that these two lines aren't connected. So this is a big problem a lot of students will run into. Even if lines look connected from a distance, if we zoom in and we see that there is a little gap, they will not join properly and cause problems later. So I'll delete this curve, start the control point curve again, and I have my O snaps disabled because I know that what's important is lining up right here on the grid. Okay, so I'll click here, I'll click here, and I can verify by selecting these two and hitting join, and down here at the bottom of the screen it says two curves joined into one open curve. So I know they're touching really precisely because they can be joined. Then I'll follow up with my polyline tool, again with O snaps disabled, because I'm snapping to the grid. And I'm just kind of left clicking throughout here. Like that, and like that. Okay, so my new curve, while it looks pretty much the same as the old curve, I know it snaps exactly to the grid, and I also know that these planes that I want to be totally flat instead of slightly tilted are flat relative to the grid, so that's all good. Select them all, hit join, and then I can move this fellow away, type in unlock, and then delete my origin curve, select the new one, enable my O snaps, and then move that back to the origin. So I've got this nice little illustration right here. Okay, so to make our first pushpin, which will exhibit double curvature and be sort of the most accurate version, I want to see all of my viewports again, and I'm going to pick this command called revolve. Now, revolve asks me to create an axis around which the revolution will take place. So an axis is going to be a line that you turn something around. It's the same with rotation. So I'm going to make the center of the pushpin shooting all the way down in the same direction as the needle, the axis for the revolve, and O snaps help me do this. So I can use the O snap to pick the tip of the profile at the far end, and then also up here at the front. Now you want to watch really carefully for the questions it's asking you. The start angle here should automatically be 0, but somebody may have been noodling with your program, so make sure it's 0 and enter. And then the revolution angle, or the amount of degrees that the revolve will take place around, should be a full 360, so make sure that's there as well. And then to witness what we've created, we can change the viewport to a shaded view, and you can see we've got a pretty accurate Pushman model there, but one that features double curvature. And so the main offender here is this little shape right there, which curves in this direction, but then also around in this direction. So while it looks like a great digital model, we will not be able to resolve this as a paper model.